protons in a cation. In the cation, you don't care about the number of the electrons or the mass number. All I want to see is the number of protons. I can see the number of protons from the atomic number, and atomic number is usually at the bottom. Mass number here at the top and proton number at the bottom, but I need the proton number, atomic number only. Give me 3 protons. Atomic number, give me the count of the protons inside the atom or the ion. Question number 2, recognize the symbol of deuterium. I have 2 or 3 isotopes. I have 3 isotopes for the hydrogen. The hydrogen has one called proton, one called deuterium, and one called tritium. They are all isotopes, means they have the same number of protons, they have the same atomic number, same number of protons, but different number of neutrons. This one has 0 neutrons, so the mass number is 1. This has 1 neutron, so mass number is 2. This has 2 neutrons, so mass number is 3. So these are isotopes we have because they have the same number of protons but different number of neutrons, or the same atomic number but different mass number. Atomic number symbol is Z and mass number symbol is A. So for this one, which one is deuterium? It is H12. This one is the proton, this one is the tritium. These two are not hydrogens, not hydrogen atoms. So let's determine the number of subatomic particles in ions. To find the number of protons, again the protons is the atomic number, so all you have to look for is the atomic number. Here I have 17, so the atomic protons will be 17. I have 13, so protons will be 13. I have 11, so protons will be 11, and I have 16, so protons will be 16. How to find the number of neutrons? The number of neutrons, you have to find it by subtracting the number of neutrons, the number of the mass number at the top from the atomic number at the bottom. 35 minus 17 is 18. 27 minus 13 is 14. 23 minus 11 is 12. 32 minus 16 is 16. So always find the number of neutrons by subtracting the mass number minus atomic number. What about the electrons? If it is an atom, the number of electrons is the same as the number of protons. If it is a neutral atom, it has no charge, it has no plus or minus, the number of electrons is equal to number of protons or the atomic number. If it is an ion, it can be a cation, which is a positive, a cation. A good way to memorize the name of the cation is that there is a plus here. So it is a positive ion. Here the number of protons will be more than the number of electrons. So you have to always subtract the number of electrons. Here 3 plus, so subtract 3 from the protons, it will be 10. Here 1 plus, so subtract 1 from the 10. So it is cations, then it is a positively charged, then subtract. If it is an anion, which is a negatively charged ion, it has a negative charge, you have to add. So here is minus 1, so add 1 to the 17, it will be 18, so add. And here 2 minus, so add 2 to the 16, it will be 18. Now question 4, identify this one's the diagrams that represent atoms. If you need atom, you have to have the same number of protons, represented always as P here, and same number of electrons. So it's represented as E. Where is the one that has positive protons and negative electrons equal? This one has 1 proton and 1 electron. This one has 2 protons, has 1 proton and 1 electron also, and this one has 2 protons and 2 electrons. C has 1 proton and no electron, so they are not the same, and E has 2 electrons and 1 proton, so not the same. Which one has positive ions? The one that has cations or positive ions has more protons than electrons. This 1 proton and no neutrons, so it is a good candidate. It is the right answer. And the negative ions are the one that has anions called have more negative electrons than the protons. Here has 2 electrons and 1 proton only, so this is the correct answer. Choose the correct answer to complete the following. The number of protons in an atom is represented by its atomic number. Again, the number of protons is the atomic number. Locate the diagrams that represent an atom with the atomic number 2, so it has 2 protons inside it. This one proton, 3 protons. This one has 1 proton also. So the only correct answer that has 2 protons is this one. Locate the model. Choose the correct answer to complete the following. Question 6. The mass number of an element indicates the number of protons plus neutrons. The count of protons plus neutrons is equal to the mass number. Locate the models that represent an atom of atomic symbol X21. Okay, so if you have X, the symbol is X. 1, the proton number, atomic number is 1, so it has 1 proton, and the mass number is 2, and we said in order to find the number of neutrons, subtract the mass number from the proton number, atomic number. So 2 minus 1 is 1, so it has 1 proton and 1 neutron. The only diagram here that has 1 proton and 1 neutron is this one. This has more neutrons, this has 2 protons, this has 1 proton and no neutrons, so this is the correct answer. An atom is represented by the atomic symbol XAZ. The A is the mass number and Z is the atomic number. Take care, don't be confused. Most people think that atomic number starts with A is the A. No, the atomic number is Z. And the mass number is the one that's called A. So for example, bromine here, this one has atomic number of 35 and mass number of 80. How many protons? The protons is the atomic number, so it is 35. If he asked about the number of neutrons, we will subtract 80 minus 35. The isotopes, the same we explained here in the hydrogen isotopes. These are atoms of the same element. They should be of the same element. You see here, they are all hydrogen atoms. They are all hydrogen atoms. They have the same number of protons. They all have 1 proton because they are the same element. If they have different number of protons, they wouldn't have been the same element. And they have different number of neutrons. Accordingly, they have different mass numbers. They have different mass numbers. So I will say the definition here. The isotopes are elements which have the same atomic number or the same number of protons and they are from the same element, but different mass number or different number of neutrons. Locate the models that represent an isotope of hydrogen H1 and 1. Take care, he is not looking for H1 and 1. Don't make this mistake. Some people looking for H1 and 1. He is not looking for H1 and 1. This is H1 and 1. This one has 1 proton. And how many neutrons? H1 and 1, 0. So this has 1 proton and 0 neutrons. That's why it has mass number of 1, because 1 minus 1 is equal to 0. But he is not looking for this one. He is looking for the brothers of this one. And the brothers of this one has either 1 neutron or 2 neutrons. So he is not looking for H1 and 1. He is looking for either 1 and 2 or 1 and 3. This one has 1 neutron in addition to the proton, and this one has 2 neutrons. So which one you can find here? This one cannot be the answer because it has 2 protons. It's not an isotope. It's not even an hydrogen. It's not a hydrogen because it has no 1 proton. It has 2 protons. This one has 1 proton and 1 neutron. So this is the deuterium. This is the deuterium, 1 proton and 1 neutron. And this one has 1 neutron without protons. This is the wrong answer. This is the right answer. Again, don't look for H1 and 1. You are looking for the brother. So don't look for the diagram of H1 and 1. If you want to draw these ones yourself, you'll draw it like that. This has 1 proton only and no neutrons. This has 1 proton and 1 neutron. This has 1 proton and 2 neutrons. That's why the total is 3. The total is 2. The total is 1. So take care. The mass number is the total things in the nucleus. Okay. Later we'll know that they are called nucleons also in the next questions. So let's see question number 9. Drag and drop each atomic particle to its matching property. It's positively charged. What's positively charged? Of course, the protons held in shells around the nucleus. So the electrons are found around the nucleus in shells. What is the meaning of shells? In layers. So this is the nucleus, the blue one in the middle, and there are layers which contain the electrons. Electrons are found in the form of shells or layers. It's different for isotopes of the same element. We just explained that the isotopes has different neutrons. It has a negligible mass, means a very, very small mass electrons. The protons has a mass of 1, the neutrons has mass of 1, electrons has a mass of 1 over 1840. That's a very small mass, that's negligible mass. It has a neutral charge. The neutron is the one that has neutral charge. So proton has positive, electron has negative, and the neutron, the name is neutron, so it has a neutral charge. Consider the following diagram. Choose the correct answer to complete the following sentence. What represents a positive ion? What represents a positive ion? Positive ion, so you need something that has similar number of protons and electrons. No, it wouldn't be an ion, it would be an atom. So we need something that has more protons than the electrons. It has 3 protons and 3 neutrons, no electrons at all. So this is the answer. What about B? Why B is not an answer? It has 1 proton, orange one, and 1 electron, so similar, 2 protons, 2 electrons, 1 proton, 1 electron. So in these 3, they are all atoms. Why? Because they have similar number of protons equal to number of neutrons. 1 and 1, 2 and 2, 1 and 1. But this one is the only one that has 3 protons and 0 electrons. 0 electrons. What are the isotopes? You are looking for 2 diagrams that have the same number of protons. So the orange ones are equal. Here 3, 1, 2, and 1. You cannot have any of this except B and D. But is this B, D, and correct? If it is isotope, they should have the same number of protons, and the number of neutrons should be different. The number of neutrons should be different. How many neutrons? Neutrons are the blue ones. Here 1 and here 0. So this is correct. B and D is correct. Choose the correct answer. Again, we are talking about the masses. We said the unit of the mass is 1 AMU for proton. Take care. Don't say 1 gram. For proton, it is a very tiny particle. You cannot even say it. So its mass, of course, is not 1 gram. It's 1 AMU. And the mass of neutron is 1 AMU. Again, we said the electron is very negligible mass, 1 over 1840. That's a very tiny mass that can be neglected. So it's a negligible mass. Choose the correct answer to complete the following sentence. Nucleons are protons and neutrons. Yes, whenever you see the word nucleons, he is talking about what is inside the nucleus. So this is the atom. It has a nucleus and it has electrons around it. So it has electrons around it. So what is inside the nucleus? 2 particles inside the nucleus. The protons lies inside the nucleus. The neutrons lies inside the nucleus. That's why collectively we call them the nucleons. If you asked what are the nucleons, the protons and neutrons are the nucleons. But electrons are outside, so they are not included. What is the atomic number of Cl? The atomic number of Cl, if it is Cl 35 and 17, again, atomic number is the number of protons, that's 17. Mass number is the number at the top, that's 35. Number of neutrons by subtraction, 35 minus 17. The number of electrons is 17, because he did not say this is an ion. He said this is a nucleus, so this does not say any positive or negative charge. So number of electrons equal to number of protons, that's still 17. What if he said Cl minus? Now it's negative. We said when we have negative, we add the electrons. So we added 1. Why we added 1? Because Cl minus 1, not minus 2 or minus 3. So 17 plus 1 is equal to 18 electrons. So this one, Cl, has 17 electrons around it. But if you made Cl minus, so you have now 1 extra electron added, that will be 18 electrons, not 17. Let's see how can we find the average molar mass from natural abundance. So how to find the average molar mass? The average molar mass is trying to find the average of anything we add and subtract. Let's see, I have a group of students, one like KG students, one of them is 100 centimeter, one of them is 110, another one is 100 centimeter, another one is 110, and I need to know the average height of these children. What I'm gonna do, I'm gonna say that I have 100 2 times, so I will just add these 2 together, this all heights together. I will say 100 plus 110 plus 100 plus 110 over 4 students. Or I can say this is 100 multiplied 2 times in addition to 110 multiplied 2 times divided by their count, which is 4. I'm gonna do the same thing here. I have some of my silicon atoms of weight, their weight is 28. What is the natural abundance? Natural abundance means here 50% of the students' height was 110 and 50% was 100. Here 92.2%, 92.23% mass is 28, and 4.670% of them, their mass is 29. And let's make this a little bit smaller so it will be enough to put all in one sentence. And let's add the last one. And the last one is 3.1% multiplied by 30. So what is the count of this? Here I had 4 students, but here I had 92 plus 4.6 plus 3, so 100. So what I'm gonna find is the average, the same way that I found the average here, I'm finding the average here. So average, also average mass. Multiply all these numbers. Don't forget here is plus, not this is plus the same way you added here. So here is plus and here is plus. I'm getting the average mass. So it's like if you have a bag of silicon atoms and you try to get these silicon atoms and measure every one of them and see its weight, you will find that 92% of these atoms has a mass of 28, while 4.67% has a mass of 29 and 3.1 has a mass of 30. How come they have different masses? Because they are isotopes. We said they all contain the same number of protons but different masses. So in order to answer such questions, make the equation like that, divide it by 100, and you will find the answer to be 28.1 gram. What if I told you I want to do the opposite? Like I give you this value and I told you some of these numbers are missing. Well, it's easy just to find it by math. So in the next question, by math, I'm gonna find out the numbers here. So this number I have given you now, this is the percentage, how many silicons has the mass of 9 or have mass of 28, and how many of silicons has the mass of 30. So I'm trying to find the percentage. Here after giving you the percentage, I found the average, but in the next question I'll give you the average and ask you for the percentage. So I will write the same equation here. Let's write the same equation. I have 2 isotopes of chlorine. Both of them has the same number of protons. That's why they are called isotopes. Atoms of the same elements. That's why they are called isotopes. But different mass number. Why? Because different neutrons. This has 35, means it has 18 neutrons. 35 minus 17 is 18, and this has 19 neutrons. So it's what? It's 20 neutrons. That's why it has 20 neutrons. That's why it has a total of 37 mass. Now I want to know, if I open a bag of chlorine atoms, how many atoms of chlorine I'll find with this mass, and how many atoms of chlorine I'll find this mass. Do you remember what we did in last equation? We write the mass of every one multiplied by its percentage. So write the mass of the nucleus, 28 multiplied by its percentage, or what we call natural abundance, how much it is there. So I'll write every one its mass by its abundance. I don't know the abundance for this one. I'm looking for it. What is the abundance of the 35 chlorine atoms? What is the abundance? So he's looking for the abundance number 1. Abundance number 1 for 35, or what I will call abundance 35. Then add it to 37. I don't know what is the abundance of 37. I cannot say A 35. I cannot give a value like that, because if I give another unknown, I will be having 2 unknowns. So multiplied by what? This is the abundance of 37. But now I have 2 unknowns. It's very difficult. And what is the percentage again? Over 100. You said here over 100. Okay, how can I make these 2 into 1 unknown so I can solve it? What is the average? He gave me the average. Yes, he gave me the average, 35.5, the average. So the chlorine atoms bag, if you open it, you will find a certain mass of it, a certain count, which is 37, and a certain count which is 35. So a certain percentage with 37 mass number and certain percentage of 35, and the average is 35.5, means that most of the atoms have a mass of 35. But because these two constitute all the bag, so it means the total percentage for these two is 100. If this is 35, if this is 25%, if the first one will be 25%, what will be the other? The other one will be 75. If the other one is 50%, what will be the mass of the other one? 50%. If one of them is 10%, what will be the average mass of the other one? What will be the mass of the other one? 90%. So if you know that this is equal to x unknown, this will be 100 minus x. So 100 minus the average mass of 35. So the other one will be 100 minus the average mass, because the total will be 100%. To make this easier, I will just call this one x and call this one 100 minus x. So the first one of this one, its mass will be x, and the other one will be 100 minus x. The rest is to find the x. Either you can find it on the calculator or you can make it by math. Now multiply 35.5 by 100, so 35.5 multiplied by 100 equal to 1 multiplied by the numerator of the left one, so 35x plus 37x minus 100x. So multiplied by 37 multiplied by 100 minus x. So let's multiply these two together. It will be 3550. 35x plus 37x multiplied 100 and multiplied x. So 37 multiplied by 100 is distribution 3700. 37 multiplied minus x is minus 37x. Now if you put these values on the other side, so let's try to put this one, move it here, so it will be 3700 minus 3550, and let's put these two together on the other side. Let's put this on the other side, it will be minus 35x, and put this one from the negative on the other side, it will be 37x. So you want to say that 2x is equal to 150, so x is equal to 75. This means that the percentage of the first one is 75. It means that out of the every 100 atoms of chlorine that you have or you can find, you will find that 75% of this chlorine atoms, its abundance. Means how can you find it in the nature? It's abundance. How can you find it in 75% of the chlorine atoms has a mass of 35, has a mass of 35. Okay, what is the other percentage? It is 100 minus x, so it is 25. So 25% has a mass of 37. This one has mass of 35. That's why the number is mostly 35. It's closer to 35. The average is closer to 35 than the 37. So the average is showing here as 35.5. Of course, it is closer to the number 35 because it's like if I told you I have a class and this class has students 100 kilogram, 100 kilograms, is 100 kilogram, 100 kilogram, 100 kilogram, and one of them is 150. What will be the average mass? Is it closer to 100? If you calculated the average by adding these two and divided it by the count, you will find that the average is closer to the number 100 than 150 because there is only one student with the mass 150. Now we'll be having more questions. If you have understood all of these questions, you will find here in the notes. I'll give you the link where to buy these notes from. If you want more questions and more practice and more exercises, you will find in these notes, plus the ones that we have just answered. This is 7.1, and see you in the next video in the playlist for 7.2.